Alrighty, guys. Now I am gonna do the complete and balance worksheet here. Actually, let me make sure I have the key on hand. This is conversions 3. I'm just gonna do this one just so that we're extra firmed up on that. I have it done somewhere. Nope. Okay, must be in my folder back here. Sorry. This one is one that I'm pretty confident I can do, but I just want to make sure that. Yeah, here we go. Alrighty. Alrighty. So, whenever I do a complete imbalance, whenever I see something like a reaction where there is only one thing on the left side here, one compound, they're combined together, there is no plus, and there is no other reason that it could be. The only thing that can happen between these two is they break apart. So what I'm going to do incorrectly, albeit I'm just going to write, I'm going to separate the two elements here. And while I'm doing this, I'm going to write down the type. We all know the type can be decomposition, combination, single replacement, double replacement, or combustion, at least the ones in this class. And this one, it's going to be decomp. I think you guys can identify the types pretty well. This is decomp. But one thing that you have to remember and pay attention to is the diatomic elements, which is going to be have, which is hydrogen, no, which is nitrogen, fear, which is going to be fluorine, sorry, of is going to be oxygen, ice, which is going to be iodine, cold, which is going to be chlorine, and then beer, which is going to be bromine. Okay. Let me make sure that those are all. Yeah. All right. So those are all of them. Is have no fear of ice cold beer. Cold, Cl, chlorine, beer, Br, bromine. Hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine, okay? Those are gonna be the diatomic elements. And every other element besides that is not gonna get a subscript of 2 when it's written by itself. Whenever we come down to this equation here, I see oxygen. Oxygen is the most well-known diatomic element besides hydrogen. So I'm going to put a 2 there because by itself, it can only release by itself if there's another oxygen atom for it to connect, for it to bond to. It's just the way that it likes to work. I don't know. That's just how it is in nature. But what I do notice here is whenever I put that 2 there, that means that there's 2 atoms of oxygen on this side of the equation, but there's only 1. So I add the coefficient to the entire compound here, which not only makes it so that there's 2 oxygen on this side, but there's also 2 strontium. And so go ahead and put that 2 there. This one's pretty simple. This one is basically the same thing up here, but in reverse. We've got a diatomic element plus a metal. Well, I'm going to look at the charges here because I want to get the formula exact. This is also going to be a combination because it's one element plus one element is going to equal one compound. So that's going to be combination. When I think of one compound at the end, combination. I think compound, combination. I don't know. Compound, combin. Somehow it works for me. So we're going to look at the charge here and we're going to pull up the periodic table. Magnesium, Mg, is going to be a 2A element, which is a 2 plus. Notice for this one, it was decomposition. We didn't have to look at the charges of the elements because it was given to us like as a compound, but because we're forming a compound, we're going to be the ones writing the formula for the compound that we have to be the ones to decide what the chemical formula is going to be. So we look at the charges. Magnesium, whenever it's an ion, these two by themselves, by itself, what's the charge of this one? This one, it's not going to have a charge at all. It's not going to have a charge at all in nature, right? But in order for these two to combine, they're going to have a charge because that's what pulls these two together is one of them gets charged, the other one doesn't. And this happens for a multitude of reasons, but we'll go, uh, the upper advanced levels of chemistry will tell you why, but all you have to remember is that in order for two regular elements without a charge to combine, they have to have it like their bonds have to be messed with in order for them to get that charge. So magnesium is 2 plus and nitrogen is going to be 3 minus. So right here, I am just going to write on this side MgN. I'm not gonna worry about the co or the subscripts yet. But on this side, I see 2. I'm gonna have 2 and 3. Don't worry about the subscript on nitrogen here because it doesn't matter. We're forming a new compound. The subscript for here is not going to carry over. So the only way we can balance out 2 positives and 3 negatives is by cross multiplying, by making it so that this one is going to have 6 negatives. So this one, 6 negatives is going to be 3 times 2. This one, 6 positive is going to be positive 3 or positive 2 times 3. So it's going to be Mg3 in 2. But what that does on this side of the equation is, oh, well, I have 2 nitrogen on both sides, right? There's 2 nitrogens there and 2 nitrogens here, but there's 3 magnesiums here and only 1 over here. So what I have to do is just add a little 3 there, and we're good. Now here we go to a harder one. This is where we have to really identify the type to see what's going on here. So this one that's by itself is going to be reacting with this compound here. And the only way that it's going to be able to react with this compound is by kicking out one of the elements here. Here we have hydrogen and we have bromine. Hydrogen is going to be the one to go away from, because the hydrogen in this compound is kind of acting like a metal would, an ionic compound, if that makes sense. It is a lot easier to kick the hydrogen out and for the aluminum to bond with this one than for hydrogen to bond with aluminum there. It just doesn't work because they both have similar properties. They both want to bond with a anion, a negative charged atom. So what's going to happen here is this one's going to move right here and the hydrogen's going to move out and they're going to swap places here. So what we're going to have is aluminum bromine. I'm not going to write the subscripts. I'm not going to worry about it. I'm just going to make sure that I know what elements are going to be in here. So here we go. We have hydrogen bromine. And I think you can tell that only one element got changed. Only one element got replaced. So we're going to call that a single replacement, SR for short. You don't want to write all that, understand. Now we're going to come back here to the formula. H is one of these diatomic elements. It's always going to be H2. Whenever it's by itself, whenever it's not connected to a compound, it's going to be H2. Written in law, like Mrs. Bosch says, it's sacred. You can't change it. Now here, whenever when we're writing the formula for a compound that we are creating, we have to make sure that the charges balance each other out so it's neutral, because all compounds are neutral, because they have no point to even be bonded together if they're not canceling each other's bonds out. There would be no reason for it to do that. They want to have no charge. So aluminum is always going to have a 3 plus charge, right? And bromine is always going to have a -1 charge. So all we have to do is add a 3 to the subscript of bromine, because one negative here times 3 bromine is going to equal those, it's going to cancel out those 3 positives over here. Does that make sense? Because we only need one aluminum to have those 3 positives, but we need 3 bromines to have 3 negatives. And so now what we've done is we have 2 hydrogens over here and 3 bromines over here. So what we're actually going to have to end up doing is we're going to have to make this, these are going to have to equal each other. And the only way they can equal each other is by finding the lowest common factor of them, which is going to be 6, right? It's usually 6. Like up here, it was 6. 3 and 2, you multiply them together, you get 6. So what we're going to do is we're going to put 6 over here. Why are we going to put 6 over here? Because that is going to be the least common factor between these two. And I'll show you here in a second. So we'll just switch. So we'll switch. We'll have 3 over here to the hydrogen, and we'll have 2 over this entire compound so that we can get 6 bromine. But we also have to take into account that it also makes aluminum. There's going to be 2 aluminum atoms here. So let's cancel out that 6 here. Let's just start back over here. We have 3 bromines and 2 hydrogens, but we only have 1 and 1 over here. So in order to cancel those out, we're going to have to switch. We're going to have 3 hydrogens, 3 times 2 hydrogens, and then 2 times 3 bromines. And then boom, then we can put 6 here. Then whenever it comes to aluminum here, we've already had this 2 here to equal the 6 bromine so that they can cancel, so that they can be equal on both sides. So then we're also going to have to add the coefficient 2 over here. So it's going to finish out looking like 2Al plus 6HBr creates or reacts to create 2AlBr3 plus 3H2. All right. There's going to have to be 2 aluminum atoms that come in contact with 6 hydrobromine atoms to create 2 atoms of aluminum bromine plus 3 atoms of hydrogen gas. All right. Now this one, we're going to move down to 4. This one, I see O2 in the reactants. I think to myself, like it looks like it could be a double replacement, but I see O2 in the reactants. That's going to be combustion, sorry. Combustion. Alrighty. And she was nice. She wrote the products here. We see how we had to write the products for every single one except this one because it's, you kind of have to realize that a hydrocarbon, when it reacts with oxygen, because oxygen is really reactive, it makes it combust and it messes the bonds up so much that we create carbon dioxide and water. And that's how it's always going to be whenever you see any carbohydrates react with oxygen gas. Okay. And that's what, the easiest combustion reaction, the definition, the blueprint for a combustion reaction. The thing about these ones is that they're very hard to balance because these are going to be the ones that you're going to probably have to double the entire equation. But we're going to see with this one, all right? What the easiest way to balance this out is by starting with the carbons and the hydrogens. So I am going to start, okay, I see carbon here is 10, but there's only 1 here, so I'm going to put 10 carbons. Then I see 10 hydrogens, so I'm going to put 5 times 2, which is going to get me 10 hydrogens. But wait a second, that means that I have 10 times 2, that's 20 oxygens plus 5. That's going to be 25 oxygens. Well, I have O2 over here. I don't just have O. If I had O just by itself, which would never exist because it doesn't react, it's a diatomic element. It can't be that way in nature. You can't just release 1 atom of oxygen in the form of gas. It has to be 2. So this one, I'm going to have to divide by 2. It's going to be 25 divided by 2. Well, I can't have a fraction in my coefficient. So I'm going to have to double this entire thing. So 2 over this entire thing. And I'm going to carry these. It's very hard for you to tell what the coefficients are, but I'm going to rewrite it for you, okay? So we double everything. So it's going to be 2C10 H10 plus this 2 multiplied by the 2 that's being divided, it's just going to be 25 over 2. And then that's going to produce 2 times the 10 is going to be 20 carbon dioxide plus 2 times the 5 is going to be 10 water. And in order for this reaction to happen with this with these reactants, it's going to have 2 atoms of C10H10 plus 25 atoms of oxygen gas, which will then produce 20 atoms of carbon dioxide and 10 atoms of water. Alrighty, now we're going to move on to number 5 here, which if you know this one was a single replacement, then you see 2 compounds over here, and these 2 are going to be the ones that switch. Or I guess you could, they're basically going to switch. This one, then the nickel is going to come over here to the phosphate, and the potassium, the K, is going to come over here to the nitrate, and that's what we call a double replacement, right? So we're going to write the products over here. It's going to be K. I'm not even going to worry about the subscripts right now. It's going to be KNO3 plus NiPO4. I know it looks ugly, but just bear with me, all right? So K is going to have a positive charge of 1. NO3, nitrate, is going to have a negative charge of 1. So right there, they're balanced out with just 1 and 1. So I don't have to do anything to that formula because I wrote it, just writing it as just 1 and 1 was correct. It just happened to be that way. And you can find the charge of nitrate in your cheat sheet. PO4 though, let me pull up my cheat sheet. I do believe is -3, but let me just check here. And it is -3. So, and nickel here is, it looks like it's going to be +2. See, you see the Roman numeral there? She's trying to tell you that it's +2, but you could also figure it out because if there are 2 nitrates, which are a -1 charge, those are going to only have a, they're only going to be able to bond with a nickel 2 because there's only 1 nickel here. And in order to have -2, you're going to have +2. And there's only 1 nickel, so it's the whole nickel is +2. But that's besides the point. So we have -3 and +2. Let me write this for you. -3 and +2. And so what we're going to have to do, we're going to switch them out. But we're going to find the most common, the least common, the lowest value of the factor that they have, which is 6, right? And so in order to make this 6, you just put 2, and in order to make this 6, you put 3, right? And then we erase this on, boop, boop. Oh, and I erased that on accident, but that's okay. Alrighty. So we just put that in I back, in I3, PO4 2. Now, we check for balancing issues. So what I see here is I'm going to start with the polyatomic ion here. And I see that I have 2 phosphates and I only have 1 on this side. So right off the bat, I'm going to write a big old 2 right there. And that means that this potassium is going to be 2 times the subscript 3, so it's going to be 6. So I'm just going to go right off the bat. I'm going to put 6 here. Then I'm going to think, okay, well then, if there's 6 Ks there now, but now there's 6 nitrates. Well, there's 2 nitrates on this side. So in order to get nitrates to be 6, I just need to multiply it by 3. And hey, if you look at that, there's going to be 3 nickels over here and 3 nickels over here. And so that's the way that if you balance by doing the polyatomic ions first, sometimes it'll work out in your favor that the coefficient that you put over here will actually be the balance, like the subscript that you put over here to create the new compound for the formula. And that's something that you can pick up on, but it isn't always the case. And sometimes, like if it's not like that, it's going to be pretty hard. All right, we're going to work to number 7. Nitrogen trihydride. What this is telling me basically is that this is a covalent compound because I see the prefix tri. And so when I see nitrogen trihydride, I see nitrogen, that's only one, and then trihydride, that's going to be it's NH3 because there's 3 hydrogens. You just take off the what do you call it? The hydrogen. You take off the gen and you put IED to make sure that you're signifying that it is a compound. And it's going to be the only reactant. So this means that the only thing that they could do is break apart. And well, I know that these two are in fact part of our first 2 diatomic elements. So I'm just going to put 2 here and 2 here. And also because they are breaking apart, it is called decomposition, blah, 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 blah. You can figure that out, how to spell that. I just write decomp, she'll understand. It's just mainly for you. So what I notice whenever, so we've got the formulas right? Because these are diatomic elements and nitrogen trihydride, you can only have 1 nitrogen. It's a covalent compound, nitrogen, 1 nitrogen, trihydride, 3 hydrogens. Now we have to balance it. We have 2 nitrogens over here and 3 hydrogens over here. So let's make some mistakes. Let's just start out, let's put 2 right here. Well, if there's 2 right there, that equals 2 over there, but that means 2 times 3, there's going to be 6 hydrogen. Well, all I have to do is put a 3 here because 3 times 2 is 6. So I have 2 nitrogens and 2 times 3, 6 hydrogens, 3 times 2, 6 hydrogens. Boom, done. Now we're going to move on to number 8. Oh goodness, we see hydrocarbons. You know what? When I see hydrocarbons, I always think I'm probably going to have to double the formula. I'm probably going to have to double the entire formula in order to balance it. So whenever we see combust too, that's a pretty good signifier that I think this reaction is going to be combustion. Blah, blah. All right. With molecular oxygen, which whenever you see molecular, that means the element form, or it usually signifies, you know, hey, this is a diatomic element to form hydrogen dioxide and water. Okay, we can do this. C2H6, they've given us the formula right there, plus molecular oxygen, which is going to be that O2, forms, that's the key word for it makes the products. We put the arrow there, CO2 plus H2O. Alrighty. Now, what I like to do, I need to start off by balancing the carbon first. All right, well, there's 2 carbons over here and 1 carbon over here. So I put a 2 here to balance those carbons out. Then I see there's 6 hydrogens over here and only 2 over here. Well, I need to put a 3 here to make that 6 and 3 times 2, 6. Alrighty, now to work on the oxygen, which is the pain in the ass. All right, 2 times 2, because O2, 2 times O2, that's going to be 4 O's. That looks like 40. We're just going to do, there's 4 oxygen plus 3 times 1. It's going to be 3. So that's 7 oxygen. Well, 7 over 2 can't really work because, you know, that's a fraction as a coefficient. So like I said at the start of this, I see hydrocarbon with um, an even amount. I think, I gotta probably double that entire fucking thing. So what am I gonna do? I'm gonna double every coefficient, but I'm not gonna double the formulas. Make sure that you do not double the formulas. You only double the coefficients whenever you get into this situation. So it's gonna be 2 carbon or 2 C2H6. So I kept the formula the same. The coefficient is just different. The multiplied by 2, the divide by 2 cancel out, so it's 7O2 forms 2 times the coefficient, the past coefficient 2 is going to be 4, CO2. And then 2 times the past coefficient 3 is going to be 6, H2O. And now we're going to check. So I have 2 times 2, that's 4 carbon. Well, there's 4 carbon over here. 4C, yeah, carbon's good. 2 times 6, that's going to be 12 hydrogen. 6 times 2, that's going to be 12 hydrogen. Now here comes the hard part. 7 times 2, that's going to be 14 oxygen. And over here we have 4 times 2, that's going to be 8. Then plus 6, because 6 times 1, the subscript on this oxygen is 1, but we don't normally write it, but it's okay. And then 6 plus 8, boom, that is 14. And there's that one. Alrighty, now we're going to do aluminum reacts with copper 2 nitrate. All right, so this is just base aluminum, just the element aluminum, and aluminum is not one of our diatomic elements that we have there. So it's just going to be by itself. You don't need to put a subscript on it. We're just going to add copper 2 nitrate. Okay, well, copper 2, I'm just going to write copper, and then nitrate is NO3, which is one of the polyatomic ions, which has a -1 charge. But copper, our copper here, has a +2 charge. So I am going to put this in parentheses and put 2 there, because you need 2 nitrates that have a -1 charge to cancel out the +2 charge from 1 copper. I hope that that makes sense. Alrighty. You have that. And I see this here, and I see these products, and I think, well, I see one element plus 1 compound. I think, that's going to be a single replacement, because these guys are going to switch. Because this guy isn't going to be the one to switch. He's the anion. It's the cation, the positive charge. The positively charged people are going to be the ones that are like, no, let me bond with the negative guy. No, let me bond with the negative guy. So those two are going to switch. That's going to be called a single replacement. And now I'm going to write the new formula over here, which is going to be aluminum, which typically has a +3 charge, nitrate. And we're just going to ignore the subscripts for now, that we'll need to do. And copper, ignoring the subscripts, it's also not one of those diatomic elements, so I don't have to put a subscript 2 there, so it's just going to be that. Now I have to think about the charges again. This one's going to be 3 plus, and this one's going to be 1 minus. Well, what do I have to do? I got to even this out so they even want to bond with each other. So 1 times 3 is going to get me -3 to cancel out the +3 there. Now I have Al NO33 plus copper. Well, I see that these are in conflict because there's 3 nitrates over here. Well, there's only 2 nitrates over here. So I'm going to flip them. I'm going to put the coefficient 3 over here, and I'm going to put the coefficient 2 over here, so it makes it 6. All right, so I see now that what that has done is that has made 3 copper over here on this side, so I have to equal it out on this side, so I put 3, and that means that I've also made 2 aluminums over here, so I've got to even that out and put 2 aluminums over there. It takes a lot of trial and error, but you just gotta, whenever you see a bunch of 3s and 2s next to each other, you just gotta think, I'm definitely probably gonna have to use 6 here. All right, now we're gonna go down to this one, sodium carbonate. All right, carbonate is a polyatomic ion, and it has the formula CO3, and it also has a -2, and sodium is Na, and it has a +1 charge, so it needs 2 of those positive ones to cancel out the 2 negative charge from the singular carbonate, and that reacts with calcium, which is Ca, has a +2 charge, and hydroxide, which is a polyatomic, which is OH, that has a -1 charge. So I'm going to have 2 OHs here. 2 OHs. And this is going to form what? Well, I see 2 compounds. I see 2 compounds over here. There's going to be two elements of this compound and two elements, well, there's going to be two groups of elements per compound here. And I'm just going to say this is going to be a double replacement because the sodium is going to replace the calcium and the calcium is going to replace the sodium. So what I see is going to happen is we're going to get sodium hydroxide in a OH, which this one, sodium is a positive one and hydroxide is a negative one. So I don't need to change the formula at all. I can just leave it at 1, 1. But it's also going to produce calcium carbonate, which is CO3. But carbonate is a -2 and calcium is a +2. So we can also leave this one at 1, 1 for those subscripts. You have to remember the subscript on this entire element, this entire polyatomic ion there is 1. It just, imagine that it has that parentheses there, but the 1 is invincible along with the parentheses, okay? But now I have to balance this thing. And right off the bat, I see that there's 2 OHs and 2 NAs. And I see that those two have kind of bonded together here. So I'm going to put a 2 over here. And I see 1 carbonate, remember? Those invisible parentheses with 1. I only see 1 calcium. So boom, we're done. That's all we had to do for that one. Let me make sure that's right. And yep, boom, it is. Alrighty. Now I'm going to clear all of this and I'm going to scroll down here so we can get the full, oh, here we go, the full thing. So we did number 10, we're going to do number 11. All right, so lithium, that's elemental lithium, just by itself. It's not one of the 7 diatomic elements, but molecular nitrogen, boom, that is one of the 7 diatomic elements. Nitrogen is a diatomic element, so I have to put that subscript 2 there because it will only release whenever it's bonded to another one of its kind. And that's going to react. Well, I see 2 singular elements here. That means that that is a combination reaction, right? Because the only thing these 2 singular elements can do is combine. Alrighty, and they are going to form one compound, which is going to be lithium nitride. Well, whenever they form this compound here, they have to interact with their charges so that they are no longer the 0 charge elements that they used to be, in which lithium is going to form a +1 charge and nitrogen is going to form a -3 charge. So there's more negatives than there are positives, and I can multiply my +1 that I have with lithium by 3 by putting the subscript there to even out the -3 charge of the nitrogen. And now all I have to do is balance it. So right off the bat, I see what I like to do is I like to start with the anion first here because I see that there are 2 over here and there's only 1 over here. So I'm going to make this a 2. And now there's 2 nitrogens on both sides, but what I did to this one is I made 2 times 3, there's 6 lithiums, but thank God that I started with the anion so that I could just put a 6 there, because if I had started with the lithium, I would put a 3 here, and then I would be like, oh shoot, there's two nitrogens over here and only 1 over here. I'm gonna have to do that. Oh, and then I'm gonna have to change that and be a 6. Which you'll get there in the end, but I would recommend whenever you have a formula like this, starting with the anion or the one that has less than whenever it's not equal to the molecular. If you have a diatomic element that forms into a compound, you know what I'm saying. We're going to move on to number 12. Alrighty, this is going to be a more difficult one. So we're given the formula for this one. So I am just going to write this down as the formula and reacts. So that means plus lithium is going to be Li, which is a +1. Hydroxide is going to be OH, which is a -1. So we don't have to have any of subscripts. 1 and 1 is going to suit them well because they both cancel each other out. So we have lithium hydroxide. and one's good. And I see two different compounds here with two different elements slash group of elements there, polyatomic ions. And so I see that this is going to be a double replacement because the the hydrogen, which is acting as a cation, and the lithium are going to switch places. They are the only thing that can really happen between them is that they switch places. And so that is going to form, whenever I see H right here and an OH right here, I want you to think, oh shit, this is going to make water. This is going to make water because those hydrogens are going to want to go over there. They're going to want to switch. That's what they're doing in the first place, right? You're getting hydrogen. They're swapping with the lithium hydroxide. They're switching. The lithium's going to come out. The hydrogen's going to come in. So it's going to be hydrogen hydroxide or H2O, water. And then we're going to also have uh, lithium phosphate, which lithium is a positive one, like we have here, but phosphate is a -3 charge. You can look at that on your cheat sheets on the first page for the polyatomic ions. So what am I going to do? I'm going to have 3 lithiums that are of that +1 charge to cancel out that one PO phosphate a polyatomic ion that has a -3 charge. So now that we have all our formulas checked out, now we can balance it. And the easiest way to balance whenever you have created um, the water, whenever you have hydroxide and the H over here, is to first ignore the right side, only focus on the left side here and do the HOH trick, which is going to be I need to have the same amount of H's as I do OH's. And so I put a 3 over here because there's 3 hydrogen over here. I need to put 3 over in because I can't mess with the formula and just put 3 right there because that messes with the charges. They're not gonna be bonded together if the charges don't cancel out. So I have to put a coefficient there. And then that means, oh, okay, well, I'm going to have 3 plus 3. That's going to be 6 hydrogen. Or 12 hydrogen, sorry. No, no. 3. 3, yeah. 3 plus 3, there's going to be 6 hydrogen. 2 hydrogen times 3 is going to be 6 hydrogen. Let me make sure that's right. Yes, it is. Alrighty. Sorry about that. You gotta kind of keep track of all the hydrogens there. So then I come over here to this one. I see there's one polyatomic ion there, 3 lithium there, and 3 lithium there. Boom, piece of cake, easy. And that is the complete and balanced worksheet done. If you guys have any questions, just let me know.